Afternoon, everyone.
Afternoon.
All right, so first of all, thank you for joining us. Thank you for having us back, some of us back in our second year of reInvent. And happy Thanksgiving to everybody. Thank you for being here the week after Thanksgiving. This is going to be a fun event, I promise. And we're going to talk about some real meaningful things that healthcare organizations are doing, leveraging technology as an enabler, as a business transformation enabler. So we're in for a good discussion. We'll try and keep about 10 minutes for questions. And I think I want to make this interactive and have some Q&A at the end too. So feel free to I think maybe if there's a mic, come up to the mic and ask the questions. So why don't we begin with some introductions? Jeff, I'm going to ask you first since you're at the end. Why don't you just speak a little bit about yourself, your organization, and how you got here in the second year in a row.
Clearly, I didn't burn something down the first year. Hi, I'm Jeff Hook. I'm the Chief Information Officer for a community healthcare organization called Nuvance Health. We practice in both Connecticut and New York in the Hudson Valley in the western side of Connecticut. As a Chief Information Officer, I've been with the organization about 5 years. And I got here by seeing the need to stop transporting data, but to transport logic to our data. And so it was very important for me and for my organization to start to take data as a very valuable asset, quantify it, and put it in a single place.
Wonderful. Elizabeth?
Hi, everybody. I'm Elizabeth Estes. I'm the Executive Director of the Open Source Imaging Consortium, also known as OSIC. And we work right now primarily in rare lung diseases. So how many of you have ever heard of idiopathic pulmonary fibrosis? A couple hands, like 2 or 3 hands, maybe 4 hands in the room. Kills as many people in the United States as breast cancer, and no one's ever heard of it. So what we believe is that technology can be used in an open source fashion. We're the largest global database for idiopathic pulmonary fibrosis in the world. And we have data from all over the world. And what we believe is that we can use technology and use machine learning to diagnose sooner, because right now it's a 26-month path to diagnosis. Imagine all of a sudden you get a cough and you go, and 26 months later, you finally get told you have a fatal disease. And your first question is going to be, how long do I have? And the doctor's answer is, we have no idea. We believe we can use technology to help figure out progression, who will progress, who will be a slow progressor and a rapid progressor, and we can do better than that, and then also response to therapy. Right now, there's only 2 drugs, and that's sinful in the world that we live in. And so the goal of OSIC is to use data and great minds. It's sponsored by all sorts of pharma companies, imaging companies, and all sorts of really cool startup and medium-sized AI companies around the world. And we believe we can make a radical difference on behalf of these patients and their families and their caregivers.
Wonderful. Yigal?
I'm Yigal Oren. I'm the Senior Director of Software Engineering for Memorial Sloan Kettering Cancer Center in the New York area. This is the first cancer center in the world. It was founded in 1884 when cancer was a very strange kind of word. And the first hospital, by the way, created had round walls because they thought that the cancer virus has to stay in corners. So if they have round walls, it will eliminate contamination. Going to today, it's a bit kind of different. I started working in Memorial Sloan about 3.5 years ago, starting to bring technology that I work a lot with in my previous life, working for financial industry and trading systems, to bring more real-time, more faster to market type of attitude to the work that is being done in healthcare. Big part of it is to try to bring together the different arm of the institution. We have the hospital that deals with cancer. We have a very big research arm that deals with clinical trials, research on new drugs, research on a new type of diseases, mutation of genes, and so on. And we have also an educational part. And bringing those 3 together really is what made Memorial Sloan to be the #1 cancer center in the world with regards to the capabilities, the innovation, and the new things that come from there. A big part of it is how do we change the whole very siloed infrastructure and the way we do work, bring it together, bring automation, change the culture, not just the technology of the organization, to bring them to the cloud, to bring them to AI, and to take advantage, like Elizabeth was saying, of new technologies to better identify diseases, better treat them, and then better prolong the life of the patients that we work with.
Just a quick background on me, on myself. Abbas Moraj. I live in Boston. I've served healthcare and life sciences clients for a number of years, growing up at Mass General Brigham and another cancer center, Dana-Farber, and Optum before coming to PwC about 3 years ago. So again, thank you for joining us. Let me kick this off with Elizabeth. I'm gonna ask you to kick us off. Your organization, OSIC, tremendous organization, a nonprofit, yep. Focuses on rare diseases, specifically idiopathic lung disease, interstitial lung disease. How did this even happen? How did this come to be? And how have you used sort of technology as an enabler to drive what your vision and mission for the organization?
I have a really heartwarming story about the very beginnings of OSIC. A pulmonologist, radiologist, and industry executive walk into a bar. True story. After an American Thoracic Society meeting, and they said, you know, this was 5 years ago, almost 6 now, we believe we can use for technology to level the playing field in this disease. Because with idiopathic pulmonary fibrosis, right, it's a variable diagnosis. There's variability in the radiology reads. And unless you're in an academic medical center, chances are, no offense to the radiologist in the hinterland, like where I grew up in the middle of Illinois, but they have never seen this disease because it's rare. So they don't know what they're looking at. And so a patient would be sent home. And so this group got together and said, we should try to do this. We should build a global consortium, and we should give away open source what we learned to the world. And so they gave me a call and said, would you consider running this? And I said, I'll do it on an interim basis. You can see how good I am at keeping my word. But we're getting there. In 5 years, we've built a great database, and how we've used technology is we started, PwC helped us a great deal in the beginning, and we started and we built it, and now we've just switched over to the cloud with our partner Vita and PwC helping along the way and being a part of all of this. The hardest part for us was the data that we're getting is from all over the world. So not just in the US, so imagine, they call the disease something different, right? We know now there's nothing that we have at the moment that can automatically change those disease names and how they call them into something, into curated data. It was really important that it not just be imaging data, that we make it enriched data for our artificial intelligence and machine learning teams all over the world who are using it by adding the clinical aspects to it. And you always say to me, this is a small but mighty database, and it is. So to give it perspective, the largest database for idiopathic pulmonary fibrosis in the world is around 3,000 right now. We have 25,000. So for those of you data people in the room, you're going, 25,000? It might as well be 25 million because this disease is rare. Now, the question is it rare or have we just not diagnosed it enough, right? And we think there's a little bit of both. So we're using the technology now to bring the data in, to anonymize it using AWS, the cloud, to bring it in, to anonymize it, drag and drop, it's amazing, with a case viewer. We're annotating it so that it becomes more enriched as we go on. And really, we started in the middle of our challenges. Our first was earlier diagnosis. That's low-hanging fruit because IPF looks very distinctive on a pattern. It looks like honeycombing. It looks like honeycombs in the bottom of a lung. So that's kind of an easy. We started with progression. Is this patient going to live or die? And can we figure out which patient is going to live or die, and how long are they going to have? And so we've made a great deal of progress with algorithms for mortality to do that, using machine learning tools. And then as we move forward, we're now looking at adding other rare lung diseases, sarcoidosis, alpha-1 antitrypsin, and more importantly, and most importantly, we're starting to bring in lung cancer screens because the smoking is actually a risk factor for this. So the technology for us is input, right? And a lot has to happen with that input. CRFs, creating clinical guidelines, understanding what's important for the machine learners, be willing to move and pivot quickly if you need to do that. And then on the output side, we have algorithms that our algorithm companies have already created. We don't know who the lead horse is yet. We do challenges. We've done a Kaggle challenge. We're going to do some other challenges to try to figure that out. But the technology in this space, and I say this to all of you, We believe we can prove a model in rare disease that can be applied to any rare disease. They deserve the same benefits that someone who's suffering from lung cancer or breast cancer or prostate cancer deserve. And we can get there. The tools are there. We just have to have the attention and the focus and then be able to bring in data and really curate it in the right way. So for us, it's a game changer. For these patients, it's a game changer. And we've learned a lot along the way and made a lot of mistakes over the last 5 years, which I'm totally happy to share with any of you who want to know what we did wrong, because we'll be more than happy to tell you that.
No, that's great, Elizabeth. And for all the healthcare and data geeks out there, I know there's some out there. I see Beth Falder in the audience right there. What's amazing about OSIC is that they've integrated imaging data and clinical data, truly integrated data set. That's actually not common in the industry. I found it very rare to have a truly integrated data set. That tells you more, and we'll come to what's next, but that's the impressive part. So that's amazing. Yigal, let me turn to you. So Sloan Kettering, amazing institution, right? Maybe not as good as Dana-Farber. No, I'm kidding. But how have you thought about pathology applications, protocol information management systems, cohort groups for academic researchers, for clinicians, administrators, and employees, right? I think, Jeff, you mentioned digital clinicians, digital workforce, digital experiences for patients, right? So how have you thought about applications in your area?
So one of the things that really starts us in the right way is to get an understanding to the technology, because we're talking technology. The technology is not the main business of where we are. It's really the hospital and the patient and researchers done around it. Technology is supposed to serve those different groups to get them to be better, to be able to provide better care, better services, and to find better cures. So what we're trying to do is to concentrate and see how we can use the current technology and the current product and the current capabilities to do that. Cloud is one aspect of that, is something that help us and move the whole process to be closer to the different function that we want to serve, and also to provide better time to market, to be able to give the different department the capabilities to iterate fast, to find the different solutions, to move forward. And what we found working with PwC for the last year and a half, that to do that requires a lot of grunt work. So we had all the things around it that we were talking about, DevOps that needs to be in place, the data structure and the databases that needs to be in place, the whole interaction between the data and the systems needs to be in place. And we worked for almost a year and a half with the team that some of them are here, and really a great relationship with the MSK team, and we put all of that together. So we got to a point that the real function can now iterate in a much faster rate. So we can get different deployment of changes to systems, of capabilities out every 2 weeks, every 4 weeks. We can get them out there that before used to take months. And that's through a lot of automation and a lot of capabilities that we brought in together to make that happen. When we talk about the different capabilities around how do we deal with AI and the cloud, I'll give one example. There's a very serious process that our research department is running. And we internally have what we call a scientific data center. So we have GPUs. But we have a limited amount of GPUs. So when they run their model, it takes them about 80 days to run through the whole model, to get the results that they want, and to get to a point that they start iterating on what they got out of it. By exploding into AWS, we can take this whole process, use 100 or more GPUs at once, run it, and we found out that we can run it instead of 80 or 90 days, we can run it in a week or two. So just think in your head of what does it mean to a researcher that they can get the results of their model in a week instead of 3 months. So we can iterate now 8 times a year instead of maybe 4 or 3 times a year, and find different solutions and different capabilities to bring that to play. Other things that we...
What does it mean to the patient? Because it means the patients are getting the solutions quicker.
Correct.
for those
So
researchers.
the whole thing about absolutely the drug design, the capability to find the right drugs, the capability to find the mutations on the genes. And when you look at databases and you look at the genome, it's huge. To try to find for each patient and tailor the different treatment to that patient, whether it's the age, the origin, the race, the different mutation that patient has, all the different side effects that they have on that drug, and bring it all together. That's a huge effort. Requires a lot of horsepower, a lot of memory, a lot of collection of data. And that is what makes this whole thing a lot easier when you run into the capabilities that the cloud allows you to do. Because we can expand everything, get all the stuff, run for 2 weeks, I can shut it down, go do the calculation, do what I need to do, and then come back. So this whole iteration around helping research is one thing. The other thing that Elizabeth was mentioning is looking at imaging and looking at how image and processing of an image using AI can help diagnose better and then treat better. So what we saw through a lot of research that we're running, if you take a pathology slide or radiology image, and you just take the doctor or the physician to look through it, to identify what they want, you get a certain percentage of accuracy. If you run the AI image on that, you get similar accuracy. But when you run it combined, you get between 10 and 20% improve on both identifying the tumor and second, finding the right way to handle it. So if you just take that and you think, what does it mean to a person that has cancer to know that they can identify it earlier, know exactly what it is, and then also tailor it to the right cure to bring that home and get that person and the family of that person to be treated in a better way.
Speed to value means very different things in healthcare than it does other industries. It means life or death, right? Heaven forbid anyone in this room has gone through cancer or a family member. It's literally speed to value. And what I heard, Yigal, was cloud has given you the opportunity for not just performance, security, resiliency. I think you've used that term before, right?
Yeah.
And scalability, right? So researchers can have access to data faster, access to insights faster, right? Not just
Correct.
data, but the insights, so that clinical trials can happen faster. And yes, it takes 2.6 billion on average to make a drug, right? So certainly, I think you've already seen some of those benefits to come to fruition.
Yeah, absolutely. And one of the things, just maybe to add to that, is I worked in financial industry, as I mentioned before. So there, the time to market is how fast can I do a trade? So it's just, somebody made a little bit more money or less money or was able to do the trade. Here is people's life and their family, and you can see that. And what we see with a lot of people that I work with in MSK, many of them has family members that went through that in MSK, including me, myself, because my wife had to be treated there. And you know what it means. You know what it means to wait another day for a result. You know what it means that the doctor needs more time because they don't have the right tools to analyze things. So it makes a huge difference, both on the person and on the family.
I was just going to chime in from a wonderful research organizations represented. As an academic medical center, the speed to value is maybe the difference between walking out of the hospital or being wheeled out of the hospital. And so minutes matter, stroke, and so resilience of cloud, resilience of data, the analytics to help the radiologists and the treating physicians. It's not just speed to value, it's speed to life, speed to functionality. And if we fail either in our identification or we fail in having redundancy or resilience, then that could be your loved one went to the same hospital, but it's a matter of moments. That could be the difference between that blood clot being removed in time or not. And so those are some of the things that we think about with our technology decisions, with our implementations, with our analytics, and so that's part of the thrill as well as some of the burden that we commiserate over, and so that speed to value is very, very, very important, as a lot of you will experience in your lives.
So Jeff, so last but not least, I mean, so Nuvance Health, right? As you said, Connecticut and New York, 7-hospital regional system. But wow, I mean, cloud, I mean, you've started this journey way before, you know, some health systems even got into this. How have you used the cloud to just, you know, AWS to just drive change at your organization? Love to hear more.
Sure. Did anyone watch this morning or participate in this morning's keynote? Start with security, start with security, start with security, start with security, start with security.
What do we start with?
Location,
right,
location.
yeah.
Oh, that's real estate. So we started with a program that said we need secure. A lot of skeptical concerns, community members. I mean, we were talking about, is anyone familiar with kind of the healthcare industry, PHI, PII? Raise a hand, just kind of. So you all know that an IP address is now PHI. Yeah, that's pretty awesome, right? So we started with security, regulatory risk, and said, what type of system do we need to build? And if you've been in the industry for a while, we usually deal with 5 to 10 to 20-year-old technology. We bring data that's inconsistent. We slop it from one place to the next. And so the vision was we need a secure place to start to bring all of our data, break down the silos, and then we're going to bring logic and systems to the data rather than moving the data around to those systems. And so that was the journey that we took to both set up a secure foundation, secure organization, dip our toes into the cloud. What I didn't mention, or boss didn't mention, is we're a 5-year-old organization, and it grew out of, you know, some community hospitals to a small system to a merger that created a larger system. And again, we're still a modest size, but we didn't necessarily have the pedigree and the experience in our teams to start to do those things. And so that's where we said, we need a secure platform, we need help building a cloud platform, we need to have a very robust analytics program, and then we need to set a visualization and integrate that governance into our organization. And through the support of our board, through our CEO, we actually have a fully integrated analytics program that drives our strategic goals, drives our day-to-day goals, and creates transparency from board member view down to unit, you know, nursing unit manager view of your key responsibilities or your role in certain goals. And so we're very excited about that. We're not quite as far along in some of the AI, but that is also, I've called this the Trojan horse strategy. It was, let's get our data in a single place, then we can start to work on analytics. We can then work on app development, and we can start to work on AI, and that's really the next chapter that we're taking. Again, very excited, but again, for myself, I fight a lot of fires every day. It could be whether it's getting the imaging team ready, it could be a physician really needs a new computer. Why did he get denied? You know, it could be all kinds of fun things. And so it's exciting to have this platform, these tools, and then to partner and learn from peers sitting on this platform with me and talking about that. So again, I love what I do. I love what we bring.
That's great, thank you. So Jeff, I'm gonna dive a little deeper for the folks in the audience. There seems to be a large healthcare contingent here, right? So I'm gonna dive a little deeper into some of the analytics that what you've truly liberated the data and driving an analytics mindset in the organization, right? So so some of the analytics that you've driven, and Beth can keep me honest here, but you know, everything from patient experience and digital front door, patient safety and quality, financial metrics, value-based care. Where would you suggest someone in a similar situation? Where would they start? Where would they get the most, not just interesting, but speed to value and value for money in terms of an investment there for analytics?
First, call the boss.
Oh boy.
He's going to pay me $20 for that later. No, I think speed to value. The most important thing is, again, did I mention security? Get that secure system, understand what it is, get the concepts there. Also, your team is critical, and I know I'm probably speaking with you guys know this stuff cold from AWS. We didn't. We did a whole, is it AWS, is it Azure, is it Google? Where do we go? And so it is understand what platforms you need, understand what you want to achieve, make sure you have a secure environment. And then from there, it's pick what aligns with the needs of your organization. You can talk about the quadruple aim, you can talk about patient satisfaction, you can talk about, I wouldn't start with financials, that's pretty standard and common fare, but it's about what hasn't been exposed, but what is not that hard to get there. And we looked at patient sat as our very first test of change. And through a satisfaction element, it came from a single vendor, it came from this whole organization, and it just was a great proof of concept to bring that data, get it exposed to our CEO, get it exposed to our chief quality officer, and every president of our hospitals and our medical group, et cetera. And then we could cascade it down very quickly. And it took us a while to get data governance there as well. Everybody thought they knew data governance, and everybody thought they were an expert on what data we should have. And so as we went through this and realized data is very expensive and very valuable. And so going through those steps to go through data governance and start to use the term rack and stack, which priorities you have, and then you can start to ask your own organization, and then it creates that really sea change that the right things are getting prioritized first, and ideally you build a huge case for trust between yourself and your CEO, your board, and the rest of the executive team.
Elizabeth, I think you and Carmela have a lot of experience in that. Do you want to share yours?
I do. You know, it's interesting. He talks about the analytics that he gets at a hospital system. So my job is to travel around and get people like this to help and give me data so that we can make our database broader, right? You know, it's so funny. I said to somebody, man, if I had a nickel for every time I heard the word generative today, I'd have as much money as Bezos, right?
Notice we haven't said that word.
Yeah, we haven't
all
yet, but I'm going to say
minutes.
this. In order for those to work, you need a complete diverse data set, right? It cannot be a homogeneous data set because you're going to implicitly add bias to those generative, there it goes, I'm going to give a nickel back, AI that you're using. But what's really important about what he said, so, and remember, I come at this from a different vantage point. I'm begging them for data to help us make our database broader. But some of the analytics that he's getting, the bioinformatics that we can get from hospital systems, bioinformatics is the most underutilized, I think, tool in healthcare research today. And I'll give you an example. The disease state that I work on, mostly pulmonary fibrosis, it's a diagnosis of elimination. It takes 26 months for them to get diagnosed. So they go to the doctor, right? And they go to a hospital system like Nuvance in Connecticut, and they're going to get diagnosed and they're misdiagnosed. They're going to get given antibiotics and they're going to get steroids. And then 26 months later, they're going to get, thrown to a pulmonologist who's going to now tell them that they have this fatal disease. If I can find patterns in those bioinformatics on the ICD-9 and 10 codes, I can go out and do an educational campaign for every doctor in the United States and every doctor in the world. If you have a patient that shows up and this is what happens to them, get them referred sooner, right? So you're grabbing analytics that from a researcher is golden. And I was taught this by my friend Atul Butte from UCSF in San Francisco. He's a brilliant bioinformatic guy who went through all of the UC system and found out that they were treating diabetes like 48 different ways, right? And they went through and said, why? Why? And it was all because that's how the clinicians wanted to treat it. And so they tried to get some consistency. So those analytics that you're getting that you say, okay, we're going to get patient satisfaction, but you're also getting these other ones from a research perspective, that's golden. That's absolutely golden. And that's things that we're interested in on our side. Yeah, getting data has been, do I dare tell the story? It's been a challenge. When we started this 5 years ago, I always tell people, especially in other countries, that I was either the naive or arrogant American, you all pick. I thought 15,000 scans, which was our original goal. I was like, how hard could that be? Like 15,000 scans? I could get this in a year. So I started in the US and I went to hospital systems. And the very first one in the Midwest said to me, Elizabeth, we'll give you 300 IPF scans and clinical data, $50 a scan. And I was like, wait, I have to pay for this. Like literally. And I'm like, oh, okay, 15,000, I think we can do that. We're a nonprofit, right? I asked for the very same thing in the southern part of the US, same exact data, and I was told $250 a scan. I went to the east, the northeast, same exact data, and I was told $700 a scan. And then I went to a venerable institution, which I shall not name, and for 500 scans, they wanted $1 million. And I said, nope, I'm out. So I flew to Europe. And I got to Europe, and I remember vividly, somebody said, Elizabeth, we'll give you the scans. I'm just wondering, are you good with GDPR? I'm like, oh boy, 8 months. Took us 8 months. We did an entire project with a law firm called Wilmer Hale in Frankfurt, who looked at exactly what we were going to do and how we were going to get the data. And 8 months later, I went back to that institution in Europe, and they said, we'll give it to you, no problem. And then another one gave it to me, and then another one gave it to us. And we just had to guarantee security, 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 right? We had to make sure that there was no reasonable, because GDPR, if you're all getting data, go with the GDPR, because HIPAA's, you're good to go there. GDPR is the gold standard, right? And there's no reasonable way that it can be re-identified. And we absolutely do that. But I will say this, when you're dealing with a rare disease, patient privacy is for the well. If you're gonna die, you'll give your data. So we need to come up with some really interesting, secure, cool ways for these patients to be involved in their own progress of their own diseases. And so that's OSIC's next step in what we're doing. Getting the data and gathering the data and then curating the data, you guys, Vita, I mean, how we've curated this data, I will tell you that we did a very, you guys are all gonna laugh, very common thing when we set up the database. We were letting perfect be the enemy of good. And so we went back and said, nope, 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 we wanna do minimum viable product. So what the radiologist and pulmonologist thought we needed, and our machine learning lead from University College London thought we needed, sure enough, we went with the really little scale, and then we started adding more and more and more. We built a plan and a CRF, a case report form of all the clinical data we needed, and then we expanded that as we went on, and that's what's made this data so valuable. But it was a learning experience for sure.
So two things I heard. It's hard.
It's hard.
Right?
It's hard.
The data pipelines, getting all the data, it's hard.
It's hard.
Right? So we're not going to talk about the G word. No nickel here.
Right.
But it's hard getting. So speaking of hard, Yigal, I want to talk about MSK Mind, because I think if there's a game changer and it's hard, love for you to know. I mean, this whole conversation is about operational and administrative, not just migration, but redevelopment, refactoring, replatforming into the cloud. Like, what are your thoughts on, what have you done so far, and how have you done it? And would love to talk about the future as well. But let's start with MSK Mind.
So one of the things, talking about the difficulties, as you said, there's multiple layers of difficulties. There's difficulties in the technology side, because we're talking about serious, big amount of data. When we talk about a cancer institute like MSK, when you take all the different images and you need to scan them, each image is huge, because you need it to be with high resolution. You need to make sure that the pathologists will agree to yank him out of, or her out of the microscope and be willing to look at that at the screen. You want to be able to bring it to the screen in a speed that is good enough for them to accept it. All of that, you can find the right technology solution, right? You get high-speed disks, you get high-speed network, but that's all local. The minute you want to share, there is a problem. How do you share such a huge amount of data? Where do you do it? And that's where things like cloud come into play. Because MSK is, again, and similar to Elizabeth, is a non-for-profit. One of the things that I like about the place, and I'm so proud to be part of it, is that we focus about the patient. Our mission is to detect and cure cancer, and to do it in the best way and the fastest way possible. And that's where all the physician, the clinician, and the researcher are really putting their mind into. And they don't mind about having their name out there. Of course, they will have it. And they don't care to keep secrets, so it will be only us. What I love about this institution, they want to share. They want to be able to share with the community, with the health community.
Which is unusual, FYI.
Yeah,
it's exceedingly unusual.
It's like, for example, one of the things that MSK, the research department, work on is to find the different cancers with the gene mutation and the cure impact and the side effects. And they created a huge database that there's no parallel to it. It's called OncoKB. They put it on the web. Any of you can go now and do OncoKB and look at that, and you can find the different disease, you can find a different mutation, because they want people to be able to take that and maybe help someone. And so that kind of capability requires a lot of technology behind it. It requires technology to process it. As you said, the whole MSK Mind is an initiative that we're doing with research that brings together the different type of research that is being done and trying to combine that type of effort to collaborate on data, to collaborate on compute, to collaborate on models that are being created, to analyze the data and be able to share it. One additional thing that we do, for example, is trying to go before cancer starts. So we have a whole process now that is identify risk in people. So any person can go now to msk.org. There is a survey that you can go through and say, I have this kind of a cancer in the family. This is the relationship. I smoke. I do, and they will give you an assessment of what you should do next. What type of should you go to do testing? Should you see a physician? Should you do anything and go and work with that? And that's open to anybody. So and going back to that security issue, we always have to keep that in mind, because the last thing you want is to have a patient or a person that engages with your organization name or information get out.
And Eagle doesn't look good in orange.
Yeah. And I tried that on. It didn't look good. So security is very important. And then we talked about the data. If I need to bring that data, those are tens and tens of petabytes of data. If I need to put that somewhere, I need the right capability from the technology point of view. I need the access control, both from security and availability of the data. I need the capability to share it externally. What we are doing, for example, with the hospital, we're doing a lot of second opinion. Because we are not available outside of the East Coast at this moment, we provide those services, international and national. So people can come and say, I was identified as X, Y, and Z. I want to get an opinion from MSK because I know the name of MSK and I appreciate the capability to find out from a physician and MSK what they think. So they need to upload data. They need to upload tests. They need to upload imaging. They need to upload pathology reports. They need to bring all that stuff out. Again, you need a place where you can do it and enable clients in an easy way to do it, and also to make sure that you have all the security around it that is available only to the people that should see it, and so on. When you look at that, it goes across all the different areas. So even though we are a cancer institute, so you say other hospitals deals with a lot of different areas and department, it still has a lot of different separate and different clinicians and research areas that look at things. And they're not always in agreement about how things should be done. So what I find from a technology point of view, when we work on those things, is we need to create that kind of environment or marketplace for everybody to first trust us that we provide the right services, and second, that we're resilient enough, that we're available, that we will give them what they need when they need to, in a way that works both financially and from a business point of view well for them. And that's something that takes a while to create, because physicians and the research people like to operate on their own. And everybody, if you work in an environment like that, it's not easy to herd all those cats, because a certain area of research gets a grant. They can start their own project, they get their own AWS account, and suddenly they have their own regions there and they run on there. And then you have to go and chase it and find out what happened, because after a few months, the person that had the grant and created the system left, and now they're coming back to you and say, oh, wait a minute, the system is not working. Can you fix it?
Sounds like we need some cloud governance, Subhaya, right?
So from I remember, and Abbas, thank you for bringing me for a repeat appearance this year. I remember last year I spoke with some folks afterwards, and there's some entrepreneurs, some developers, all of you, or at least I saw a lot of hands about healthcare. And I think one of the things, and just as I hear my research colleagues talk about research, there's a lot of brain power going in. There's a lot of data being associated there. But I think there's also, as you take in context this conference, the tool sets, what I would also implore is not just take the analytics, but use the analytics to set up the next best action. And that really needs to be some of the mindset that we take either with the tools, with the analytics, because analytics are no good if you solve cancer but don't do anything with it. Or we've researched the hell out of this thing, but I can't get anybody to use it. And so whether it's for patient sat, correlation, and again, I use patient satisfaction. We have 6 pillars that we set our strategy around. We have scorecards, and I think we're somewhere around 300 different unique analytics around those 6 pillars, all built out in the last 2 years. And so what is the next best action now that you've found this data? You have the insight. What are you helping people do? And I think that's where, if I were to look to the future or look to where we're taking this now, I've built the safe environment. We've brought the data together. We have a picture, and people say, we have a problem. And then it becomes, now what? And so it's using the tool sets that either we're talking about, and I will use the, man, I'm tired of hearing different people tell me how AI is going to solve my problem. Like, thank you for bringing that to me. It's so much easier now. I didn't think of that over the past 3 years. But from those elements, we're prepared for that. If you have your data organized, if you understand, if you had taxonomy, excuse me, the challenges you're going to run into are how many different ways did we document C section in our organization? It was C dash section, C period section, C space, C underscore. And so those are some of the challenges that we run into with taking the data. We get it cleaned up, but then what's the next best action? I think that's where, as we look at whether it's Q, again, really excited about that, getting Q connected to Connect. Really excited about that. Again, that's just me nerding out.
What about Kuiper? Satellites?
There's probably some consumers of mine that would love to have satellites because they don't want cell towers and they don't want cable, but they live in Podunk. So maybe we'll get Kuiper in there too. Sign me up. But no, it's what is the next best action? How do we solve problems for people? And that's the challenge that we have to look at across the board. And I appreciate the tools and the power that we have.
Yeah, and I think, for us, it's the same thing, right? For us, we say, that's great. We can build an algorithm that says which patient's going to progress or which patient's going to die. But the question is, how do we get that to the clinician, and how do we make it matter clinically? That's our job, right? So what is technology, and how does the cloud help us do that? We got to start here so that we can give those physicians, and honestly, the pharma companies. I get people, a lot of naysayers or cynics will say to me, Elizabeth, you're just trying to get pharma to create new drugs. And I say, yeah, there's 2. My sister died of ALS. There were 2 drugs. How is that possible in a disease that we've known about since Joe DiMaggio, and we all dump water over our heads for the ice bucket challenge? The ecosystem isn't set up for speed, right? The technology's there. It's like we've got cars that go 100 miles an hour, but we're still driving on gravel roads. It's our job to figure out how to make those ecosystems right and get there quicker. And it's a big passion, obviously, for me after doing this for 5 years, because seeing it from the inside out, and I wasn't in the healthcare space 5 years ago. So I've learned a heck of a lot.
Yeah, one of the things that really we're talking about the outcome of technology, that we implement analytics, we implement AI, but the one thing that a lot of time we forget is really what do you need to make that work, to make that really happen. And that's part of the thing that is the kind of the dark side that enables us to do that. Because what we found out that to took one application and migrate it from where it is and take it to the cloud in the way we wanted to take, the first one took us about 9 months. Because we had to find out, this is not there, or the Terraform was not created in the right way, we didn't have the right thing, or JFrog was not. All the things that nobody wants to hear about, if we don't create that in a way that is like a pipeline, that you can say, I don't need to think about it. I want to use AI. How do I use it? And then you can take it and use it and really take the benefit from that fast is key. What we found in about 1.5 years that we went from a process of 9 months to take an application and take the development team and kind of step in, and I see the smile on the team that really worked with me to do that. And to come to a place that we can do it in 2 weeks, and suddenly the application is, I can build an environment, just click on the button in 10 minutes, my development environment is up and my database is permissioned, and I can start really putting data and run what I want to run there. That's a key thing that sometimes people skip. And sometimes people don't have the patience to see that through. And what we found is it comes to a lot of other things at the end. One of them is the speed, of course. The second thing is resiliency, is the capability that if your environment goes down, by clicking on a button, in 5 minutes, the environment is back up, or your data is back up. If you want to save money because your organization is not-for-profit and we don't have lots of money, you can drop your test and UAT environment during the weekend and not use them, because you know that Monday morning you click on it and before you come with your coffee, the environment is back up and you run it. All those kind of things are not there if what I call us the little people running around the screen really put all those things together and really combine them and work them. And it's hard work. It's a lot of work that requires a lot of attention to details. And then you have to change the culture of your team.
But I would also say, and you know, again, I look at this, I'm going to take the helicopter up a minute, because he's talking about that from the perspective of, you know, MSK, right? And you're talking about it from the perspective of Nuvance. I say we even need to get standards globally that are similar, right? I have no idea how to do that, but we talked about this with the RSNA. I want the RSNAs going on right now this week in Chicago. I wish there were standards of how they take a standard chest CT or HRCT for this disease, because they're all over the place. Or I wish there were standards on, we talked about the taxonomy, right?
Exactly.
We've got to figure out a way to come together and collaborate, and you know, OSIC is partly that. But it would be great if hospital systems from the US and hospital systems like we have data from Asia and South America and you know, all over the world. And if we could come together and say, how are you doing the HRCTs? Let's be consistent, because I think we've got these tools now that allow us to create algorithms that work on real world data around the world, not just first world data. And that's super important. But we've got to, you know, it's systems theory. You want to change the output, change the input. We've got to get more consistency. Like, are you guys doing the same thing on taxonomy? Are you doing it not?
Oh, definitely.
I promise you.
There's my point.
I promise you they're not.
Yeah, you would know that. My point is that I get your pain point, and I get your pain point, and then from solving disease and using AI and machine learning to really make progress, we've got to have a higher level set of standards and a higher level set of consistency. There's my soapbox moment. Sorry.
And I'll reply with healthcare is local, and you know that really creates a very interesting contrast of how we're trying to solve things and how difficult it is, because I have to meet the needs of my local organization, and I very much care about the well-being of the global health, but I have to make sure that I'm meeting the needs of Nuvance Health constituents and those who we consider our patients and consumers. And so that's, you know, setting our priorities are even set differently just based off how we operate. And I think that's a challenge that maybe policy can help, but I'll leave policy and some of those elements out of this conversation.
All right, I'll pull you out of policy.
Thank you.
And
Appreciate
all
that.
of that. Otherwise, I'll get in trouble here. But I'm hearing a theme here. Before I get into what's next, I see a word, convergence. I do see convergence. You know, Elizabeth, you deal with not just data, but pharma, researchers, right? Jeff deals with community health-based system, lots of PCPs, transactions. You got oncology, second opinions, right? There has to be some convergence for, you know, some of it to work easier for the patient, right? That's all.
Absolutely.
Eric Topol wrote that book 10 years ago, I think. I don't know what year, but y'all probably know it, Creative Destruction of Medicine. And that was the number one thing he said was going to come change medicine was the convergence. He's right. It's just taking us a little longer, and we've got a long way to go before we finally get there. But I absolutely agree with that.
That's right. So this morning, for those who saw the keynote, Adam Selipsky talked about what he's looking at the future, what he's excited about, right? He's excited about, and he showed that picture about sort of foundational models with training and inference, and then the middle layer of LLMs, and then an application layer on top of that. And of course, he mentioned Project Kuiper as well, Jeff. But if I were to, Yigal, let me start with you. I mean, the next 18 months, what are you most excited about, and how are we going to use the cloud and AWS to really drive change at MSK?
I think one of the main thing for me is what I just mentioned about research, because I find that the cloud has the most benefit for the research side in multiple areas. One is the speed to process. Second is the tools to use the AI and machine learning and derive the data and the analytics they want from that. And one thing that is even sometimes can be more important is the capability to share data, the capability to have additional data come into those models. Because when you analyze the data only for what you see in your hospital, it's one thing. But if I take a hospital from India and a hospital from Africa, and I bring the data together, everything changes. The model changes, the outcome change, the way you want to treat people change. And I think that's what is so important and so transformable in working in the cloud. And that's where I see the next step. That, of course, will impact the way we treat and the way we find different cures and medicine.
I'm hearing business model reinvention.
Absolutely.
Elizabeth?
For us, again, myopically for the open source imaging consortium, it's the ease of being able to get data in to the point of I have data coming from all over the world, and with the platform now, they drag and drop, it anonymizes, right, which is awesome. We have case viewers. People, our partners can annotate, which is a very important piece for us. There's all sorts of the ease of being able to use it for research, and then the ease of being able to have the output so that the machine learning community can take it. They can create cohorts based on kernel slice kernel size, which who knew they needed that. Slice thickness, clinical fields that we had no idea they would be as important as they are. So I think for us, it's the cloud makes our global database possible. I mean, there's no question about it. And we were on another platform earlier, as you know, and it wasn't nearly as user-friendly, and it wasn't nearly as fast and as secure. And so from our perspective, the game changer really is the fact that we can now be anywhere around the world, and they can drag and drop their files, their imaging and everything right into it, and good to go. Anonymization, we're good to go. So speed. Speed and quality, I would say.
Quality.
Yeah.
Okay. Jeff?
What was the word? Business model reinvention. I really think that's where we're at. We have a head of steam on analytics, and so it's now what do we do about it? How do we use it? How do we grab more and assist our organization? I don't know if you all pay attention, but the provider healthcare industry really has gone through some significant expense challenges, particularly around labor. And so that means, one, we have less nurses, less physicians, and we're going to continue to have less. So we have to be very efficient. We have to be very thoughtful. We have to make their job pleasant rather than miserable. And so it's really taking this data and helping them either make decisions or take some of the burden that they have today and removing that. I know that's a slight deviation for what we've been talking about, but that's what the data is going to tell us. It's going to show us how do we use it, how do we reinvent, and how do we simplify. And so that's next best option or next best action. Make it so I don't have to stay up all night documenting. Make it so I don't have to stay up all night thinking about what's best for my patients or responding to text messages that are coming in through my inbox. So that's really what we're focusing on over the next 18 months.
It's also still 20% of our GDP.
Amen.
Yeah.
So before we go to the questions, one more thing I would add is the cool part about the cloud to me is also, although we have it set up to take imaging and clinical data, we're now bringing in audio sounds because IPF sounds very differently in a stethoscope than any other lung disease. We're also bringing in unstructured data through NLP clinical notes, right? So the fact that we have these flexibilities that we never had before, I think it's a game changer for research. I really do.
Fantastic.